questions. When you hear the word derivative, what two things come to mind from what you guys saw on the video that you watched last night for homework 3? Any ideas? What do you guys think of when you hear the word derivative? Okay, good. And it should be slope of tangent line. Perfect. So slope of tangent line at a moment in time, that's also called instantaneous rate of change. Okay, so I'm looking at my speedometer and there's a speed that's being clocked, and that is instantaneous rate of change. It's the slope at a single point, as opposed to secant lines and average rate of change. Okay, problem 2, we're gonna write down, and hopefully you guys can do, so sometimes I'll do this with you guys, and this is just how it would be done if I was in class with you. If I had a document camera, I would tell you guys, hey, glance up at me at the screen if you guys need help with something. Otherwise, try to write it down, see if you can recall how to do a problem, or what, in this case, the two definitions of the derivative are. And then I'll kind of stay quiet as I write it down myself, and then you guys can just glance up and check if you got it right. But that way you're kind of guided through this. And plus, you guys are my superstar students, so I can go through certain steps without having to explain. You have to take the square root of both sides, things like that. Okay, by memory, we should have these two definitions of the derivatives memorized in our minds. This is, oh, and I wanted to say, this is not going to be on the test next week. Anything with derivatives is not going to be on the test. Okay, so this is the one that I'm going to start, because that difference quotient is the one that I'd like you guys to, both of them you should memorize. The first one is the one that we're going to use most frequently. How would you guys describe the process when you guys are doing the difference quotient types of problem? And I'm talking about, like, how does it feel when you guys are doing it? And it doesn't have to be like a good word, but just not a bad word. How does it feel when you guys are doing that problem? Does it feel like it's easy to do, or does it feel like it's tedious? Okay, well, that's good to know. So for some of us, it's really easy to do, but it is tedious. So guess what? AP test-wise, you don't have to ever simplify the difference quotient. Okay, so I will show you guys how AP questions are phrased. In the video, I went over a few examples with you guys. I sprinkled some into your homework assignments, but we're not going to spend a whole lot of time simplifying the difference quotient, because one point I want to get across is the AP test is testing you guys on calculus. It's not testing you guys on algebra or anything arithmetic. So we're going to skip, the way that they get around that is they have you guys leave things in unsimplified form. And this is not going to be my first time saying it, but you guys are going to leave things in unsimplified. Okay, derivatives, product quotient rule, those are going to be unsimplified, meaning you don't even have to simplify square root of 4. You can just leave it in your free response answers. And then we'll talk about how to do it with calculators eventually, but that's what I mean. It's like you guys don't have to do, like, if you leave your answer as 2/4 and you accidentally reduced it to 1/3, even though this was the right answer, they're going to grade you guys on this one. And so they're going to say that that problem is wrong because of that. So I'm going to highly encourage, and this is going to work against all habits you guys have learned before, highly encourage that you guys do not simplify any answers. So with that being said, for this was an actual AP problem. You were given g of x equals x cubed. Find the slope of the curve at x equals a. So I realized that when I put together my notes, I have the assumption that you guys all know how to take the derivative, and I will summarize the power rule later on at the very end, just so that it's in your notes. It's something that I don't usually have to go over because I know everyone's coming to me knowing it. Power rule is you're bringing the 3 down, right? Timesing it by whatever constant is out front. So in this case, 1 is out front, 3 times 1 is 3, x to reduce the exponent by 1, so 3x squared. Now, if they say things like, write it so that it's in terms of a instead, then my slope or my derivative, sorry, should be 3a squared. Okay, so when does the slope equal 12? Can I have you guys think about that for a second and then go ahead and set up an equation for that? And glance up if you guys get stuck. I'm relying on you guys to just trust in yourself and try the problem on your own. And then see if you guys, when you look up, if you're doing the process correctly. Anytime you guys need a hint, you can always just glance up. And I wish I could freeze the screen so you guys aren't seeing it as you're going, but feel free to glance up if you guys need help. So good. And you solve for it the rest of the way and you take a square root. So how many possible answers do you get when you guys take a square root? Good. Plus or minus 2 is your solution. And again, this is asking for when the slope is equal to 12, not for finding the slope at 12. Okay, so it's the y value is equal to 12. All right, so of all the types of questions that you guys see on the AP test, I feel like this one, if we can get it down from the start, it's going to help us because we will see this type of question all the way through to our series chapter. Okay, so write the equation of a line tangent to a curve. So you got a curve. They want you guys to write the equation of a line tangent to a point at x equals 4. The problem is that when I'm thinking of writing an equation of a line, I noticed that at Fountain Valley, a lot of you guys came from Algebra 1 classes that emphasize y equal slope intercept form. And we're not going to encourage that in this class. You guys are, if you guys are given a point and you're asked to write the equation of a line, you're going to use point slope form. So please use y minus y1 equals m times x minus x1 and leave it unsimplified. Do not put it into slope intercept form. So you're going to write all your tangent lines, equations of lines using point slope form, and you're going to leave it like that because I can't tell you guys how many times I grade a free response and that is right, but then the slope intercept is wrong. Okay, so as you are doing this problem, what value are you guys missing? Write the equation of the line tangent to the curve at x equals 4. So we got the x coordinate. We don't have the y coordinate. What do you guys plug back into? How do you guys get the y coordinate? Okay, good. Plug x back into the original equation, and we get g of 4 is equal to 4 cubed, which is 64. Okay, we always need the point, so we got 464 as our coordinate point, and then we need the slope. And the slope in this case, again, when I think of derivative, I think of slope. So I'm going to plug in g prime into g prime, my x value, which is 4. Okay, so we plug 4 into our derivative and we get 3 times 4 squared, which is then 48. Okay, putting everything all together in point slope form, y minus 64 equals the slope 48, x minus the x coordinate, x minus 4. Okay, and then in the follow-up question, they're asking for a normal line. Now, actually, I don't know. I'm teaching a solid geo now, and I'm saying that you guys learned it in geometry, but I don't think you did. I think you guys actually learned this possibly in Algebra 2 trig. Does anyone know what a normal line looks like? Underline it in red. Relationship between normal line and tangent line. I'm pretty sure we learned it in Algebra 2 trig. Okay, if I drew, oh, very nice, Tim. Through that point, I drew that line. It's perpendicular to the tangent line. Okay, so that means the slope of two lines that are perpendicular to each other are what we call opposite reciprocals, right? So M is opposite reciprocal. to the derivative. Okay, so what would that mean our slope is then? What is our slope for this problem at x equals 4? Perfect, negative 148. And it's still going through the same coordinate point. So we're going to rewrite the equation of a line with the same exact coordinate point, but the slope is going to be negative 148 in place of 48. And we leave our answers. Do not put into slope-intercept form. Okay, then we get to a section. Now this is how they're going to test you guys concept-wise on the difference quotient. So this is like kind of like a big AP note question. You're probably guaranteed to have at least one of these in the multiple choice section. And they do this because they're testing your knowledge of, can you tell, let me erase this portion right here. Can you tell that that's actually the definition of the derivative? So problem 4 is it's kind of guiding you guys. It's telling you that the derivative is equal to this. So yes, you're going to look at these limit problems, and I saw some of you guys attempt to apply the limit here. You wouldn't, because then you get something that is you can't determine any further. So what you would do is, okay, well that looks like f of x plus h minus f of x all over h, plus I notice all of these have over h on the bottom where h is going to 0. Then you're going to think, oh, this is the derivative. Okay, then take a step back. What is my original function here? So I go to the f of x plus h part, and if this is the x plus h part, then if I remove that x plus h and I replace it with just back to the original, just x, that's going to give you your original function. So my original function is just e to the x. The point that it's being evaluated at is, it's given to you guys in that one because it's guiding you, but it's the value that is where x normally would be for x plus h. So in this case, you have 2 plus h. So this is really an expression for the derivative of e to the x at x equals 2. Now, what would the question look like more on the AP test? That's kind of a little off because it gives you guys too much stuff. So if you look at an AP problem, if you flip open an AP practice book, you might see a problem that looks like this. It doesn't have any directions, and it just is presented as a limit problem. So at first glance, you might think, okay, this is a limit problem. I'm just going to do direct substitution. However, again, if you notice the over h, the limit as h goes to 0, you're going to think, this is actually asking me for the derivative. Okay, so then I have to figure out, okay, what's my original function? My original function, go back to where the f of x plus h part is, remove and replace 0 plus h with x, and my original function actually is just cosine of x. And then the point is, go back to the f of x plus h part and look at where x is. X is 0. And so now to actually fully answer this question, if this is the definition of the derivative, the question is really asking you guys, what is the derivative? Okay, what is the derivative? So once I figure out my original equation, I'm actually going to answer the question this time. My question is really asking, what is f prime of x? Any ideas what f prime of x is for this problem? Does anyone know what the derivative of cosine of x is? At this point, this is just recalling from last year. We haven't covered it, but does anyone know? Want to take a guess at it? Excellent, negative sine of x. And to take it so you guys have kind of like a 3-step process. You're going to figure out the original function. You're going to figure out the derivative. And then the third step is you're going to actually find out what f prime of 0 is. So if I plug 0 into my derivative function, negative sine of 0 is 0. So the final answer, what you guys would see in multiple choice options, are just the 0, or they might put they might trick you guys and put the wrong trig evaluation, since people might think sine of 0 is pi, or whatever the case might be. So now if you guys can try to do this and glance up if you guys need help. Okay, I'm going to stay quiet for a minute. Try to do problem 6. Okay, hopefully you guys wrote square root of x, and I rewrote square root of x. I posted, by the way, I assigned it on through your Khan Academy account. Some videos, if you guys need refreshers on just basic derivatives, there's some videos on there to help you like do things like rewrite square root of x as x to the 1/2 before you take a derivative. And then in which case, the next step is this question really is asking me so first step is what's the original function? Second step is the question is asking for a derivative. So power rule here, we're going to bring the 1/2 down times the constant out front, which is 1, x to the 1/2 minus 1, which is negative 1/2. And then the third step is evaluate the derivative at the point, which is 9. And so if I plug everything in, bring the negative exponent down, rewrite it as square root of x, 1 times square root of 9. And what is my answer? What is the answer some of you guys got to? Sure, Andrew. So how did I get square root of x? So I'm going to go to the part, go to the part where it's f of x plus h. So this is supposed to represent f of x plus h. I'm going to look for the x plus h part, the constant plus the h, and replace that with just x. And that's square root of x. Does that make sense, Andrew? Okay, perfect. All right, so now if I take what I just discussed algebraically about the slope of the tangent line being the derivative, I'm going to go back to this, go to this graph now and start applying it like I know. So we have a series of tangent line segments of a piecewise function, and here they're asking me for the derivative, which I am going to think of as the slope. So I'm going to give you guys a minute. People whose name starts with A through H, can you guys do A? And then as you finished it, and then look at what letters I'm writing here, but I through K, L through N, or maybe M, and then first name, N through S, T through B, W through Z. Okay, so first name. If you guys have your first name N through A through H, you're going to do A, so on and so forth. And then once you guys get an answer, can you guys go ahead and input it into the chat for me? And as people are inputting it, if you're done with your problem, can you just make sure that it makes sense to you? And I will go over the tricky one is C with you guys. But everything else, go ahead and glance at the chat. I'll summarize in a bit. And if you guys see me filling my screen in with people who put answers in the chat, that means that those are correct. And feel free to type your answers into the chat. And one thing I also wanted to bring up, if you guys ever want to, you don't want to like, seem like you don't know what to do, you guys can always ask me private chat and ask me if something is right or wrong. Keely, both are right. Yes. -1 would have been a good guess. All right, we're going to wrap up. Does anyone have D? Or maybe no names start with that. Okay, perfect. All right, and just to summarize, you guys are finding the slope of those lines. You know, pick 2 points, do rise over run, or find the slope using the 2 coordinate points algebraically. So I did not see anyone write, and it's fine. That's actually leading us into the next discussion. Is if we think about the definition of the derivative, if we go back to it, you don't have to do this, but if you go back to the idea that the derivative is really just a limit, then when a derivative exists means that the limit has to exist, coming from the left and coming from the right. So if I look at if I look at the limit on this side, what the derivative is of this function and of this function, there is that piece of the function and then the other piece of the function, we see that they approach different values. And there's this sharp corner that occurs there. So what happens is that the left-hand limit and the right-hand limit, the left-hand derivative and the right-hand derivative, are not equal to each other. One's -1 and the other side is +1. So we say that this derivative fails to exist or does not exist. Remember, a derivative is a limit. So if the limit coming from the left and the limit coming from the right are not equal, then that means that the derivative doesn't equal each other. So therefore, it doesn't exist. So how can we tell when this next section? Differentiability means recognizing on a graph when something is not differentiable. And there's 3 cases when it's not differentiable. You have something called a cusp, and we're going to do an example with the cusp down below there, but you have a tangent line, and as you guys approach, it's going to positive infinity, and infinity in terms of a limit does not exist. So as you approach this x value, this limit doesn't exist, therefore the derivative doesn't exist. So this is a cusp. Corners don't exist, absolute value functions, the derivative does not exist there. It does exist at all these points, it exists, but it fails to exist here. Okay, same thing with vertical tangents, because if I try to find the slope at this point right there, it's undefined, just like what you guys learned in Algebra 1. Okay, so those are the 3 ways in which the derivatives fail to exist. Now, I threw the right-hand comments in the places of discontinuity, because then we start getting all of our things confused, like limits, continuity, differentiability. So I wanted to make sure that, just going back to discontinuity, what are the 3 ways in which it could be discontinuous? And which one of those 4 words do not belong in the group? Jump, removable, infinite, and oscillating. Which ones are places of discontinuity? Or to make it easier, in the chat, good. Oscillating does not belong in the types of discontinuity. Oscillating means that's a limit that does not exist there because it bounces back and forth. Okay, so example 1 and 2 on here, they're asking us to show that the absolute value function is not differentiable at x equals 0. So I'm going to do it 2 different ways. For this one, I'm going to break the absolute value function, which you've done before, into a piecewise function. On the left-hand side, we have the line -x. So for all values x less than or equal to 0, we have the line -x. If we look at the right-hand side, it's +x. And we really could put the equality either on the top or the bottom, it doesn't matter, of x is less than or equal to 0 or x is greater than or equal to 0. Just pick one or the other, it won't matter. And then if we're taking a look at the derivative, because you guys know how to take the derivatives of these, what is the derivative of -x? So let's say left-hand derivative versus right-hand derivative. What's the derivative of -x? And this is for x is less than or equal to 0. -x has a 1 exponent, right, you guys? -1, yes. Thank you, Andrew. So -1 is the left-hand derivative. What is the right-hand derivative? Excellent, 1. If a derivative is a limit and on the left-hand side you have -1 and on the right-hand side you have 1, well, these two guys are not equal to each other. So therefore, our conclusion is that the derivative does not exist or fails to exist at that point. Okay, so now when I'm looking at x to the 2/3, which is a function that looks similar to the cusp example that above, and you're thinking, okay, well, how do I do this one? I can't break it out into a piecewise function. So what we do is we examine what it looks like coming from the left and the right at 2x = 0, and we're examining the derivative function. So let's go ahead and this one, we don't have to break out into piecewise function because there's no two pieces to it. What we're going to do is just apply the derivative here. So y prime is another way of saying derivative. Y prime is bring down the exponent and times it by the constant out front, which is 1. So 2/3 times 1 is 2/3, x to the -2/3 power. Sorry, not -2/3. Bring down the 2/3, and 2/3 minus 1 is -1/3. Okay, I always suggest that you guys rewrite negative exponents, especially when you guys are trying to analyze. It's 2/3, 2 over 3 x to the 1/3 power. And so if that's my derivative, both on the left and the right, because it's not a piece, what I'm going to do now is take it back to the second definition of the derivative, where we're looking at what happens when it's approaching a particular value. So the a value here is 0. And how is it different for coming from the right of the function that I'm examining is the derivative function. So this is the right-hand derivative versus the left-hand derivative. Limit as x approaches 0 from the left. Okay, so if I'm coming from the right, if I do a direct substitution in x = 0 into that fraction, I get that the bottom is 0. So therefore, there's some type of infinity in my answer, right? That's how we've been attacking these limit problems. And then we do a sign analysis. If I plug a number to the right of 0, like 0.1, into the fraction for the right-hand derivative, then I get a positive value. So we're going to positive infinity. If I plug a number to the left of 0, like -0.1, and take the cube root of a negative number, I'm going to end up with a negative number. So negative infinity coming from the left. Okay, so I probably could have stopped at infinity. The moment you guys get infinity as an answer for a derivative, that means that the limit doesn't exist and therefore the derivative fails to exist. So this is us showing that even if those are both positive infinity or negative infinity, if you have any sort of infinity, our conclusion is that the right-hand and the left-hand derivative do not exist. So therefore, our conclusion is that the derivative does not exist. Okay, so here is where I got, where I started to run out of time here. So I'm skipping over the next 2 pages. We'll come back to graphs again. And I just wanted to wrap things up with this page, which I normally don't do, but I wanted to make sure you guys have it on a sheet of paper. If today felt okay to you guys, you do not have to watch the optional videos. It's on power rules and derivatives of the 2 basic trig functions, sine and cosine. Okay, so the easy way of doing things that we've been working on above is to bring down the n and times it by whatever constant's out front, which in this case is 1, and then deduct the exponent by 1, so n minus 1. So we're going to skip example 1 because we've done something similar like that. So example 2, can I have you guys write what you think f prime of x is here? What is f prime of x? What do you do with this problem? X to the e power. Or take a minute, write it down. And if anyone wants to attempt it in the chat, see if you guys have an idea of what to do for that. Okay, in the interest of time, I'm going to do the problem. E is just a constant, so E times 1 is E, and then x to the E minus 1. So E is 2.7, oh, good, thank you guys. E is 2.71, so you leave your answer like that, and then you finish off the problem by plugging 2 into x. So it's not going to look pretty, but that is my final answer. We don't approximate it using a calculator unless it's a rounded answer in the multiple choice or you do have a calculator, in which case this is perfectly acceptable for us to leave our answers like that. Don't round yourself. Don't do 2.71 minus 1. Okay, the derivative of e to the x is also on a con video if you guys want to watch it. But if you remember from the period yesterday, they said that you guys did learn it, and it's the con video goes over why it is e to the x. As you're examining the slope at each point, you notice that the slope, if you were to map it, actually is e to the x, which is odd. And then so applying that rule, we're going to do example 8 really quickly. If you have multiple polynomials, or you have a polynomial with multiple terms, you're going to take it term by term. That's one thing you guys can do with derivatives. So the derivative of this would be 2 times negative 3, which is negative 6, deduct 1, x to the negative 4. Rewrite square root of x. That's another con video. You can write x to the 1/2, carry down the 1/2, x to the negative 1/2. And we are going to leave our answers like that. We do not have to simplify. And then I'm going to stop us here and come back to, I did do this example with the other period, but I'll stop and then come back to that example.